This video will continue our discussion of triple integration by working another example. We're going to find the volume of the solid bounded by the graphs, and they gave us these equations. Let's point out our surfaces first. This is our surface right above, and it cuts through. And then they actually give me this as well. This is going to be very important. This says the xy plane. So we don't want any of the surface that goes below, which means I need to find the surface in question, which I have underlined there. I need to find when it crosses and figure out when is it above and which is it below. There's a couple things that are going to help us with that. We have this y equals 0. That's going to be our x-axis. We also have x is greater than or equal to 0, so that means it's in the first quadrant, right? First quadrant, first octet, since we have this as well. And the question is here, normally what I would have done, I think, looking really quick, is that this is a parabola turned upside down. That's my purple graph there. It's shifted up 5, turned upside down. So we have that purple graph. That's my parabola. And normally I think I would have went over here and I would have shaded like all of that, right? And said, hey, that's all above it. But what actually is happening is our graph is going to dip the surface right there on that red line. And I'll show you how I got that red line. It's going to dip underneath and go under the XY plane. This here tells me not to do that. I don't want that part. So what we're going to try to find is we're going to find where it crosses the xy plane, which means z is 0. So I set this equal. I get x cubed equals 8, which tells me x is 2. And that's where I got my graph there. I know, and just think about the surface. As x approaches 2, right, it's going to be positive, right? If x is 0, I get 8. If x is 1, I get 7, but as soon as we get to 2, I get 0, and if I go past 2, I go underneath. So I'm wanting it to intersect there. So that's the area I want. I don't want the little slice there past the red line. I just want that. All right, let's set up our bounds and then set up our integral here. Zoom back out. All right, our z is going to be caught between the xy plane, and the actual surface. Y is what I'm going to do next because I can see it here. I go from there up, so I can see what y is caught between. Y is caught between the parabola and then 0 at the bottom. And then x, we just look at the numbers. Well, it starts at x equals 0 and goes over to x equals 2. So again, setup, drawing that picture is the key. It is the most difficult part. Tons of practice just setting up is going to benefit you quite a bit. So the volume for this thing, x is caught between 0 and 2. Y is caught between 0 and the function, the parabola. Z is caught between the xy plane, which is 0, and the surface in question. If I want a volume, I put a 1 there. And then I put dz, dy, dx. And there's my setup. If I were to work this out, they asked us to on this one, but again, I'm going to save video time because I trust that at this point you can do integrate, right? We've done a few of these examples. I'm hoping at this point you can work that out. The volume, when we work that out, hold on, I lost my page. The volume is 148 over 3. That will solve is the volume of that figure. Again, I encourage you to work that integral out. I'm just trying to save video time. And then, again, assessment will be a lot of setup.